Today we're going to continue on in our conversation from yesterday. We introduced rectangular prisms and finding the surface area, and we had our conversation about serial and how we would go about designing that box. And today we are continuing that thought with prisms and finding surface area, but we're going to look at two different types, focusing on triangular and trapezoidal prisms. So you see here in front of you, I have a couple different real-world examples of where you might see some of these. The Toblerone chocolate bar is probably one of the more famous triangular prisms. And some features just that I want to highlight before you go in and start finding surface area is that you see that there is a triangle base, and I'm highlighting it there for you. And all prisms have two bases that are parallel and congruent, and we talked about that with our rectangular prisms in the cereal box from today or yesterday. But this Toblerone bar you see has two triangle bases. That's what they would sit on. And then all of the other faces of this prism are rectangles. So this one would be a rectangle, and you can't see the other sides, but it would be laying down here on the base of a rectangle. And so those are just some key features to look for, and they're going to help as we start calculating surface area, looking for those and identifying them before you get started. I also have a picture here of a tent, which is another triangular prism. You can see it has two triangle faces that would be congruent, and this other one you can't see through the tent, but it would look something like that. And then you would have all of the other faces here as a rectangle. The surface that it's laying on is a rectangle. So the rectangles are your main features, but you have another polygon that would be what we identify as the base. And then lastly, I do have a picture here of a trapezoidal prism. You see here that there's this trapezoid, and I've never actually seen one of these guys in real life, but they look kind of good. You would color in right here, this is a trapezoid, that would be your base, and there would be a matching one back here that's kind of cut off by the image. And then all of our other faces here, you see on this side we have a rectangle going off and connecting my two bases. On top we have another rectangle. And so those are just some features to keep in mind as we go through and calculate our surface area. So those notes that are in front of you, you see up at the top that our question that we're exploring today really is, how do we find the surface area of these two prisms? All of the same principles and systems that we talked about yesterday with finding surface area are going to apply today as well, but we're just going to be looking at these two prisms in particular, and then I might throw a couple others at you, but you'll use that same system to calculate surface area. So the first step that I would like you to take when you're looking at these shapes is to identify what the base is and highlight. I saw some of you were coloring or using different shading techniques yesterday, and so the first thing I would just draw your attention to is that base. And so I'm going to highlight it here on my screen. We see that this is a triangular prism, so I have one triangle base up here, and then the other one that is parallel and congruent is down here. And that will save us a step as we go and calculate surface area. Since they are congruent, we only need to calculate it once, and then in our total we can make sure to include it twice. So if you don't have formulas memorized for other shapes, I would definitely encourage you to take out your blue formula sheet. That is always at your disposal, and you may use it whenever you'd like to, and that will probably come in handy today as we explore these shapes other than a rectangle. But we're going to start off the same way. At the top of our notes, we're going to write in that formula. Since we're dealing with a triangle, our formula is 1/2 times base times height. And just another review piece from our area unit that we did earlier in the year, this right angle piece is what you are looking for to identify your base and height of any shape. You want to look in, clue into that shape, and as you see, where I see that little right angle, it's these two sides that make my base and height then. But unfortunately the picture isn't labeled in those spaces, so we need to kind of look down at where the other congruent sides would be to get those measurements. And in this case we can go in and plug in our formula that the base would be 3 and the height would be 4. Order doesn't really matter. And then you go through with your calculation and get that the area of this triangle would be 6 feet squared. But because this is the base, and I'm even going to label that in my notes, that number will have to be used twice in our final calculation of surface area because there are two of those triangles. Then we need to move on and figure out the area of each of the other sides. So I'm going to erase my coloring here to show you and highlight some of the other faces that we see. Since this is a triangle, there are different rectangles that come off of each of the three sides. So to go with our base, we should have three other rectangles, one for each side of the shape. So the first one that I see here, I'm going to highlight down in red. We're going to start off the same way in our calculations. We have area equals base times height since we are back to rectangles. I see that one side is 4 feet, the other side is 7. So when I plug that into my formula, I get 28 feet squared for that rectangle's area. We need 2 more for the other 2 sides of the triangle, and again, order doesn't matter, just kind of pick them as they pop out at you or as you see them. I'm going to go over here to this one where I see one side is 3, but I need to figure out what this side would be. And so I'm looking for another line on my image that matches this. And it takes me all the way over here to find the line that matches or is parallel to those. So the other measurement I'm looking at then would be 7 feet. So in my area formula, again still a rectangle, I would multiply my 7 and 3 together and get 21 feet squared. And then the last one that we need, again one rectangle for each side of the shape that we're dealing with, I'll go here in green, is this slanted side here up at the top. Still a rectangle even though it might be laying differently. So we'll still start off with that formula base times height. We see here that this side is 5 feet and my base would be 7 feet, giving me a total area of 35 feet squared. Now that we have each of the individual faces and their side measurements, we're going to do the same thing we did yesterday, write our surface area down at the bottom and total them all up. The one thing we just need to make sure we're including this time is that this base, we only calculated it once, but there are 2 triangles, so we need that 6 twice, plus our 28, our 35, and our 21. Go ahead and type that in, calculate that. You should get a total surface area of 96 feet squared. So as you see, very similar process. You're taking it one shape at a time, one face of the 3-dimensional figure at a time, calculating each of the individual areas and just totaling it up at the end. So my next example, we're still looking at a triangular prism, but I wanted to give you another alternative. Instead of using a right triangle this time, we're going to use an isosceles triangle, but it doesn't change anything in our process. I want you to start again with the base. I think that's the first thing we should always start with and identify. So I'm going to highlight those here on my screen. We're going to use our same formula since it's still a triangle, 1/2 base times height. This time again, you're looking for that perpendicular line to find your base and height. And it doesn't actually give it to you here, but that line down the center would be the line perpendicular to your base. So base would be 4, 1/2 times 4 times 3 to find the area of that triangle. And you get 6 centimeters squared. And again here at the end, since it's our base, we're going to have to use that number twice. And then since it's a triangle, we need 3 rectangles, one for each side of the triangle. Again, kind of start with whichever one jumps out at you first. I'm going to start with this far side over here. I'm highlighting it for you. We'll use our rectangle formula, base times height. In this case, we have 15 by 5, which gives us a total area of 75 centimeters squared. So that's one of our rectangles. We'll go through and I'll highlight another one. I see this guy here at the bottom, that it's the base that it's sitting on. And with our area formula, this time I'm going to plug in my 15 by 4 centimeters to give the base a total of 60 centimeters squared. And then our last side is kind of hidden, it's not really seen, but it's still there. It's this guy all the way over here that's made up by that far side of the triangle. It's kind of hard to see, hard to picture. So if you notice, we have a line going all the way across the top, so we need to find another line on this shape that goes that same distance, which is all the way down here at the 15 centimeter mark. And then the line that goes this direction is 5 centimeters. So you could write out that step yet again, but we did do that same measurement 15 by 5 right above it. So if you decided to take a shortcut and leave that one out, just be sure that you go back and add that twice as you add up your total surface area. So final step is to add everything together. We have two bases that are both 6 centimeters. We have two rectangles that are both 75 centimeters, and then that bottom rectangle is 60. So go ahead and total all of those numbers together, and you should get a total surface area of 222 centimeters squared for the surface area. So our third example here, I switched gears and take you to trapezoids, but we're going to go through the same process by identifying the base and working through those areas before moving on to any of the rectangle faces. So in this picture, it's actually already highlighted for you in blue, so I'm just going to go here and kind of repeat in blue the bases of our trapezoid. And the first step would be to start with that formula. Again, if it's not memorized, you should be looking at your blue formula sheet to write everything out. It's really important that that step is taken care of, especially for the trapezoid formula that has this extra parentheses piece that is easily missed. So then we need to go through and identify my two bases, which are the two sides that are parallel to each other. So you see up here I've got 6 centimeters, and then down here we're not totally labeled, so we look at the other trapezoid and we see it's 12 centimeters. So as I go through and write that out, my bases, I have 6 plus 12, and then the height is that perpendicular line. They drew that symbol for you. We're going straight up and down. In this case, it is 4. So that's the trickiest part, plugging everything in, and then you just go through with your calculations. Make sure that you're adding or doing that parentheses step first before multiplying any of the numbers together. But when you type all of that into your calculator, you should get 36 centimeters squared for that area. And then you need to go through and do the same steps for each of the rectangle faces. In this case, because we're dealing with a trapezoid, which has 4 sides, there are going to be 4 different rectangles coming off of it for you to work through. So take it one step at a time, just color the ones that are popping out to you first, and work your way through. Never assume that any of the sides or the rectangles are the same unless you have the proof that the measurements match up. So I'm going to start here at the top, this rectangle up on the very tippy top. We know our formula going back to rectangles is just base times height. We see that the line going this direction is 6 centimeters. The line here is not labeled, so we got to look around the rest of the picture, and we see down here that it is 10 centimeters. So that top rectangle will give us a total area of 60 centimeters squared. Then looking at the next one, we see over here in green, I've got another one labeled, still a rectangle using our base times height formula. Going in this direction, we see that it's 10, and going up this side, we have 5, so we'll plug those in for our base and height, and we get 50 centimeters squared. And I can already see that this side all the way over here, since these are an isosceles trapezoid, it's 5 centimeters as well, and 10 centimeters going across the bottom. So I'm just going to write myself a note that there are 2 of these. You can write out that extra step and go through those calculations, but making a note that there's 2 of them and to include that in your total at the end is sufficient enough. And then your bottom base rectangle, I want you to find the area of that and add them all together. and you'll complete this last example here and complete that for your check-in with me.